As what we were looking for was a very rare gas, helium-3. It's an isotope of normal helium that is known on Earth. It's extremely rare and very, very precious, about 10,000 pounds per gram. What we found, we found it in a particular nebula in space, a planetary nebula. And we found it in the place where it gets manufactured, the kind of star that creates helium-3. And that's quite a nice discovery to make. Well, helium-3 isn't a special gas. It has very important uses on Earth, in cryogenics, in medical images of the lung. They use helium-3. It's so rare that they have to make it now in the nuclear laboratories at an extortionate cost. And there are some ideas to mine it on the moon. Now, the stuff that we have found, we can't use. It's too far away, 4,000 light years, sadly. But it does tell you where it got made and how long it has been in the universe. It's a very late addition to the universe. It tells us about the conditions inside the star that make it, and that is a star very much like the Sun. It tells us something about how these stars evolve. Helium-3 is a byproduct of the fusion of hydrogen, as it happens in the Sun, and in some lower mass stars, not higher mass stars, they do it in a different way. But after it's formed, it's very fragile, and so the same stars destroy it again. Then at the end of their life, stars eject a lot of the material into space, and thereby enriching the universe. I mean, a lot of the carbon, the oxygen that we depend on for our lives was made that way. So helium-3 too. But exactly how much was produced, how much survived, how much was ejected, that is very poorly known. And so this tells us about how stars evolve, and it tells us also how the universe evolves. You first have to find out that's important, that there is something missing here in our understanding of the stars. Then we identified helium-3 as a missing ingredient. It turns out it's extremely difficult to detect. It can only be seen by radio waves, and it is extremely weak, and so you need a very large telescope. In the end, we used the 70-meter telescope in Madrid. It's part of the Deep Space Network, so it's used for satellite communication, but it had some spare time. And it observed for us for many days to detect this line. Now we would like to do more. We have to do other nebulae as well, but we lack the sensitivity in the telescopes. So we have to wait for the Square Kilometre Array, the next big telescope that is being built. But it will still be a few years in the future.